Good afternoon, HOD Professor A.K. Chaturvedi sir, my seminar guide Dr. Surendra Kumar Rathod sir, my seminar coordinator Shri D.P. Sharma sir, faculty members, examiner and my batchmates. I am Akash Tilak, pursuing my Bachelor's of Technology in Mechanical Engineering branch from University Departments, Rajasthan Technical University, Kota. Today I am pleased to be here in front of all of you to deliver the presentation on my seminar topic 4D printing. This is the list of contents I'll be delivering in this presentation. So first of all, I'll start with the introduction. 4D printing refers to single material or multi-material printing of a device or object that can be transformed from a 1D strand into pre-programmed 3D shape, from a 2D surface into reprogrammed 3D shape, and is capable of morphing between different dimensions. Such transformations are facilitated by heating, light, or swelling in a liquid, electrochemically, and by programming different sensitivity to swelling into various parts of the design geometry. These techniques offer adaptability and dynamic response for structures and systems of all sizes and promises new possibilities for embedding programmability and simple decision making into non-electronic based materials. Now we'll talk about history of 4D printing, how it came into act. It was during TED conference at MIT in 2012. Skylar Tibbets showed how there occurred transformations in a static printed object by 3D printing over time. It has been seen that a simple 3D structure can be transformed with time into a more complex structure. This resulted into a new era of printing involving a new dimension in 3D printing, that is time, and this was given a separate name of 4D printing technology. The fourth dimension is the time, and we can say in a simple way that the 4D printing is 3D printing with an extra dimension of time added to it. Or we can say that the changes in the 3D printed materials with time result in the 4D printed materials. And after that speech by the Tibbets, the 4D printing started to gain its popularity among the researchers and engineers of various disciplines. Now, if we want to talk about 4D printing, we need to understand basics and a little essence of 3D printing. The history of 4D printing starts with the developments and advances in 3D printing. Therefore, it is very important to know about some history about 3D printing technology, which eventually led to the introduction of 4D printing. A brief knowledge about 3D printing, its history, printing techniques, etc., will help the reader in better understanding the concept of 4D printing and its evolution. 3D printing is a technique of layer by layer printing, simple or complex structures using computer aided design under the control of a computer. Now we will talk about factors responsible for 4D printing. As you can see, there are 5 factors which are mainly responsible for 4D printing. First is the process, the additive manufacturing process. Second is smart materials. Third is stimuli. And the fourth is interaction mechanism. And the fifth is mathematical modeling. If we talk about the AM processes, we can see that there are FDM, that is SLA, SLS, and many more. If we talk about stimuli, there are physical, chemical, biological stimuli, and mathematical modeling are forward and backward production. So now there were 3 laws of 4D printing which were introduced. So 3 laws that govern the shape changing behavior of all 4D printed structures. First law: all the shape changing behaviors such as coiling, curling, twisting, bending, etc. of multi-material 4D structures are due to the relative expansion between active and passive materials. The second law states that there are 4 physical factors behind the shape changing ability of multi-material 4D structures, that is mass diffusion, thermal expansion, molecular transformation, and organic growth. And the last law, third law, is time-dependent shape morphing behavior of nearly all multi-material 4D printed structure is governed by two types of time constants. If now we'll switch to types of materials which are used for 4D printing. First of all comes the hydrogels. So hydrogels, materials that are responsive towards moisture or water, have attracted huge interest to a wide range of applications. These materials are also called hydrogels as they possess an extraordinary ability to respond towards the water or moisture. The second one comes in is thermoresponsive, that is, which is based on temperature, which is reacting to temperature. These are the smart materials that are responsive to the heat or temperature stimuli. The changes in the shape of these materials with respect to the thermostimuli are mainly due to two mechanisms: the shape change effect SCE or the shape memory effect SME. Now we switch to third material, that is photoresponsive material. Light also acts as an indirect stimuli for the deformation of smart materials. When an area of smart material that is responsive to the light, also called photoresponsive material, is exposed to the light, it will absorb, which will eventually produce the heating phenomenon in it. Fourth one is electroresponsive, which is responsive to electrical energy. Electricity is also an indirect stimuli like light, as it has also been proved to show heating effect due to the resistive nature of material through which it passes. Hence, such materials that undergo deformation due to the responsive behavior towards the electric current are called electroresponsive material. Now we will switch to the fifth, that is magnetoresponsive. That is, it is responsive to magnetic field. The magnetic field or magnetic energy is again an indirect stimuli that can bring deformation in smart materials, and those materials which are used to print 4D structure because of their deformation response towards magnetic energy are called magnetoresponsive materials. Sixth type comes in as piezoelectric. Piezoelectric materials can produce a charge when mechanical stress is applied to them. The effect of producing electric charges by the action of mechanical force is called piezoelectricity. And the last, which we have introduced in our presentation, is pH responsive. These are the smart materials that can respond towards the pH value and undergo changes in shape and volume according to the pH value. The deformation in shape in respond to different pH values make them suitable for 4D printing technology. Polymers that are pH responsive have been used in 4D printing, such as polyelectrolytes, as they can receive or donate protons on pH value change due to the presence of an ionizable side group. Now, if we summarize, this is a schematic diagram depicting all the materials we have discussed and to which stimuli they are responsive. So the next slide here, properties associated to these materials. These properties, there are three properties which are associated with the materials. That is, first is self assembly, second is self adaptability, and the third is self repair. These terms are self sufficient to describe themselves. So I'll go on with the next slide. Some of the applications in 4D printing which has increased the usability of the 4D printing is are these. Like, first is medical applications, soft robotics, self-evolving structures, aerospace, sensors, and flexible electronics. Now, if we talk about the challenges, what are the challenges that are being faced by 4D printing? So, 4D printing is a new research area that came at the advent of 3D printing technology. 3D printing itself, it is in a developing phase. Being a new field of research and only in its initial stages, 4D printing has some limitations and challenges that need to be overcome soon. The three main challenges For 4D printing, which we face are first the availability of technology, materials that are being used and need to be discovered, and third the design of the materials we need to take care. So here I conclude my presentation with the conclusion. 4D printing is an advancement of already existing 3D printing by including time, the fourth dimension. 4D structures can deform with the time depending upon the stimuli to which they are exposed. They can respond to heat, water, electrical energy, magnetic energy, stress, strain, pressure, etc. These structures can self assemble, self repair, and are self compatible with changes. That is self adaptability. 4D printing involves the use of 3D printing techniques for printing smart materials, single material, multi material, or non active material. 4D printing finds its application in medical sciences, soft robotics, self helping products, active origami, etc. There are certain challenges to 4D printing, but that can be taken care of with putting some efforts fighting them. So, here are some of the references I mentioned, and that will be all. Thank you.